take a look at this example. So for the given data over here to the right, draw a scatter diagram of the data, by hand compute the correlation coefficient, and determine whether there's a linear relation between X and Y. Now I did write this table horizontally. I just took this from the problem set in the book. So if X is 2, Y is 10, if X is 3, Y is 9, and so on. So I'm going to start by creating my scatter plot. So I have the point 210. 210, that's just going to be up there. I have the point 39, so 3 is going to be here, 9 is going to be around there. So there's the point 39. 5, 7, 5 is going to be here, 7 is going to be about there. 6, 4, 6 is here, 4 is here, and 6, 2. So there's our scatter plot. So look at that. Do you think there's a linear relationship? If that point right there wasn't there, that looks a lot more linear. If I just had these 4 points, that looks a lot more linear than if I add that 5th point. That 5th point kind of makes it look like it curves. But if you kind of visualize a line going through there, you can kind of visualize a line. So I would say there might be a linear relationship. It's kind of hard to tell with only 5 points. So I want to calculate the correlation coefficient by hand. And I've given myself a table here to help with that. So now I did kind of goof up on my table, so I have to correct this. I included the X coordinates here, but I did not include the Y coordinates. So I'm going to put a comma and Y sub I. And so it was 210, and it was 39, 57, 64, and 62. So what I'm going to do is I'm going to calculate the z-scores for each of the x's in this row. I'm going to calculate the z-scores for each of the y's in this row, and then I'm going to find their products, the products of those z-scores. Now I'm going to carry out my decimals pretty far because rounding could cause significant error in my calculation. So I'm going to carry out my decimal places to like 5 or 6 places, just so rounding doesn't mess up my calculation. Another thing that I'm going to do, it says to do this by hand, but in order to calculate these z-scores, I need to know what x bar is, and I need to know what y bar is. I need to know what the standard deviation of the x's is, and I need to know what the standard deviation of the y's is. And so I'm going to have technology do that for me. So I entered these 5 points into list 1 and list 2 of my calculator. So I have the x's in list 1, the y's in list 2, and I'm going to calculate the mean and the standard deviation of those using those 2 lists. So I'm going to go to stat and calc, one variable statistics. My x's are in list 1, and if I calculate that, then I get x bar is 4.4, and s sub x is 1.81659 if I round to 5 places. So I'm going to just write that down over here. X bar equals 4.4, and s sub x is equal to 1.81659. I'm going to do the same thing to find y bar. Now my y's are in list 2. So I'm going to go to stat and calc, one variable statistics for the y's that are in list 2. When I do that calculation, now my calculator is saying x bar is 6.4, but I know that that's for the y's. So y bar is 6.4. And the standard deviation of the y's is 3.36155 if I round to 5 places. So 3.36155. I do want to point out one other thing real quick. When I go to stat and calc, option 1 is one variable statistics. Option 2 is two variable statistics. So two variable statistics I could use when I have two variables. And in this case, I have two variables. So if I select two variable statistics, I have to tell the calculator where the x's are. The x's are in list 1, and I have to tell the calculator where the y's are. The y's are in list 2. And so if I choose calculate on that, it tells me x bar is 4.4, s sub x is 1.81659. And if I look down farther, y bar is 6.4. And if I scroll down, s sub y is 3.36155 if I round to 5 places. So I could use two variable statistics for that calculation instead of using one variable statistics twice. So I'm ready to calculate the z-scores, okay? Now I'm not going to write all of these out. I'm going to mainly use my calculator. But like if I want to find the z-score for 2, I'm going to take 2 minus 4.4, because that's the x bar, divided by 1.81659. That's going to give me the z-score for the x-coordinate 2. So if I do that, I'm going to use parenthesis, 2 minus 4.4, close parenthesis, divided by 1.81659. And that gives me negative 1.32116 if I round to 5 places again. So this would be about negative 1.32116. That's what I have right here for the 2x coordinate, the z-score, negative 1.32116. Now, if I calculate the z-score for the corresponding y value, the corresponding y value is 10. So I'm going to take 10 minus y bar, which is 6.4, and divide that by s sub y, 3.36155. So 10 minus 6.4 divided by 3.36155. So that is about 1.07093 if I round to 5 places. 1.07093. So now I'm going to find the product of those two things. So negative 1.32116 times 1.07093, that gives me a product of negative 1.41487 if I round to 5 places again. So this product, negative 1.41487 approximately. Now I'm going to do the same thing for my other 4 points. But to speed things up, I'm going to do all of the x's, all of the y's, and then I'll do all the products. So for 3 is my x coordinate, parenthesis 3 minus 4.4, close parenthesis, divided by 1.81659. And that is negative 0.77067. Now I'm going to do the same thing for 5. Now here's why I'm going to do it this way. I don't know if you know this trick or not. If I hit the second button and enter on my calculator, that will pull up my previous calculation. So all I have to do is edit the 3 to be 5, and the rest of the calculation's already there for me, so I don't have to keep typing it all in over and over and over again. So that gives me 0.33029 if I round to 5 places. My next x coordinate is 6. So again, I'm going to hit second and enter to pull that back up. And I'm going to change the 5 to 6. And so 0.88077. Okay. And then my x coordinate here is 6 again, so I'm going to have the same z-score, 0.88077. Now I'm going to do the other 4 y z-scores. So for my first point, I have 9 minus, now y bar is 6.4, close parenthesis, that's going to be divided by 3.36155. And so that is 0.77345 if I round to 5 places. So 0.77345, rounding to 5 places. Now I'm going to do the same thing for 7, and I just realized I wrote this down wrong. That's 6.4. This should have been 6.2 right there. But no harm done yet. Second and enter to pull back up my previous calculation. I'm going to change the 9 to 7. And so the z-score for 7 is 0.17849 if I round to 5 places. Do the same thing for 4. Second and enter to pull that back up. Change the 7 to 4. And so I get negative 0.71396 if I round to 5 places. And last but not least, find the z-score for 2. Second and enter to pull that back up. Change the 4 to 2. And so I get negative 1.30892 if I round to 5 places. So at this point, I have all of my z-scores calculated. Now I just need to find the products. So for the 0.39, the product's going to be negative 0.77067 times positive 0.77345. And so that would be negative 0.59607 if I round to 5 places. So negative 0.59607. Next, 0.33029 times 0.17849. So that is 0.05895 if I round to 5 places. Next, 0.88077 times negative 0.71396, 0.88077 times negative 0.71396. So that is negative 0.62883 if I round to 5 places. And finally, if I multiply 0.88077 times negative 1.30892, that is negative 1.15286 if I round to 5 places. So I found all the products. Now I need to add all of those up. If I add all of those up, that's going to give me the sigma of the x sub I minus x bar over s of x times the y sub I minus y bar over s of y. That's going to give me the top part here. So I'm going to just add those 5 values up. Negative 1.41487 plus negative 0.59607 plus 0.05895 plus negative 0.62883 plus negative 1.15286. And so that gives me negative 3.73368. Now again, I just wrote that there. That right there is the sum of the x sub I minus x bar over s sub x times the y sub I minus y bar over s sub y. That's what that calculation is, the top part of my correlation coefficient. So R is going to equal that, negative 3.73368, divided by N. N in this case is 5, because we have 5 pairs of data. So N equals 5. So I'm going to divide by 5 minus 1. In other words, I'm really going to divide by 4. So if I divide by 4, I get negative 0.93342. With the aid of the calculator, it's not extremely hard, but it is kind of tedious and nasty. And that was with only 5 points. So can you imagine doing that with 500 points? It would be a mess, which is why we're generally going to rely on technology to do this for us. Now, a couple of things I want you to notice. First of all, if you look at this data is going down as you move from left to right. So the smaller x values tend to be paired with the bigger y values, and the bigger x values tend to be paired with the smaller y values. So it would appear we have a negative relationship if there is a relationship. Our correlation coefficient is negative as a result, indicating there's a negative association. Remember, R is supposed to be some value between -1 and +1. Our value is between -1 and +1. And it is actually relatively close to -1. So because that R equals negative 0.93342, we would say that it does appear that there's a linear relationship, and specifically there is a pretty strong negative linear relationship between x and y. So the answer to C, there is a strong negative relation between x and y. And I know that because R equals negative 0.93342 is close to -1. That's how come I know it. R is close to -1, so that indicates that we have a negative association, and it's a fairly strong one. If R had been close to +1, then we would say we have a strong positive association. If R is close to 0, then we would say there's not a linear relation. So there is a potential issue, and that is my choice of saying in this particular case that there's a strong negative relationship is a little bit subjective, which can get us into trouble. What I mean by that is this. What if instead of that being negative 0.93342, what if we had gotten R equals negative 0.83342? Would you still say there's a linear relationship? Probably, but it's not as strong, right? What if R equals negative 0.63342? Would you still say there's a linear relationship? And I'm going to just keep going. What if R equals negative 0.43342? Would you still say there's a linear relationship? Now with the negative 0.93342, it's pretty clear there's a linear relationship. But when we start getting away from that, now it becomes a little more debatable. And so what happens if you look at this and you say, yeah, I think there's still a linear relationship, and I look at it and I say, yeah, I don't think there is. We want to remove that subjectivity. So we can do our first inference in this class. So in the appendix of your textbook, there is a table of critical values for correlation coefficients. It's table 2 in the appendix of your textbook. Now I've copied that right here The print is a little bit small in that table because I had to shrink it down so it would fit. So I did print another copy to try to make it a little more readable. So here's another copy of that table with a little bit bigger numbers that you can see. Now here's how this table works. Over here in the right column, we have what is called critical values. So basically these are like cutoffs. And the cutoff is going to be different for different sample sizes. So if I have a sample size of size 10, let's say, then the correlation coefficient has to be 0.632 or larger in order to say that we have a linear relation between X and Y. But if our sample size is 6, then the correlation coefficient has to be 0.811 or larger in order to say there's a linear relationship. So we're going to be able to compare our correlation coefficient for our situation to the appropriate critical value, the appropriate cutoff. Now there is an issue, and that is all of these values here are positive. Now remember, I told you before that like 0.9 and negative 0.9 really mean the same thing in terms of how strong a linear relationship is. The positive just means it's increasing and the negative just means it's decreasing, but the strength's the same. So we're going to ignore the negatives. So like if we have a negative correlation coefficient, ignore the negative and just compare your value to the value here. Now, when I say ignore the negative, what we're really doing is we're looking at the absolute value. So here's our procedure. Step 1, determine the absolute value of the correlation coefficient. So like for our problem that we just did, our correlation coefficient was negative 0.93342. So the absolute value of negative 0.93342 is 0.93342. So essentially I'm ignoring the negative sign. So that's step 1. Step 2, find the critical value in table 2 from Appendix A for the given sample size. In our problem, our sample size was 5. So if I come over here, the critical value, if the sample size is 5, is 0.878. Again, I'll pull in the bigger table so you can see that maybe a little more clearly. 0.878 is the critical value. So if for n equals 5, the critical value, which I'm going to abbreviate CV, is 0.878. So step 3, if the absolute value of the correlation coefficient is greater than the critical value, then a linear relation exists between the two variables. Otherwise, no linear relation exists. So in our case, our 0.93342 is bigger than 0.878. So there is a linear relation between X and Y. So this removes the subjectivity. So when I go back to my what if question, what if R had been negative 0.83342? Well, the absolute value of that would have been 0.83342, and 0.83342 would have been smaller than 0.878. So based on that, we would say if this had been our correlation coefficient, we would have to say there isn't a linear relation between X and Y. Now, technology. So I showed you before that I have in my calculator, I have the X's in list 1 and I have the Y's in list 2. We can use technology. I already showed you how to do the scatter diagrams, but we can also use technology to calculate the correlation coefficient. So my X's are in list 1, my Y's are in list 2. Here's how I get the correlation coefficient on the calculator. I'm going to go to Stat and to Calc. And what I'm going to do is I'm going to do option 4. Option 4 is linear regression. So I'm choosing option 4. Now on my calculator, I get this window, and so I have to tell where did I put the X's? Well, my X's are in list 1. Where did I put the Y's? My Y's are in list 2, so I have to tell the calculator that, and I'm going to choose calculate, which I'll do in just a second. If you have an older calculator, when you select the linear regression, you'll get the command linreg ax plus b. That'll show up on the screen of your calculator. You have to put where you put the x's, comma, where you put the y's. So this would be saying, find the linear regression if my x's are in list 1 and my y's are in list 2. Or you would put the appropriate list that you use. Does that make sense? You would hit enter. I select compute. And I get quite a few things on this, and we'll talk about the rest of these things later on. But look at the bottom line here. Negative 0.93342 if I round to 5 places. So I got the same correlation coefficient that I did by hand when I use the technology. If you have a new calculator, you may not get this full display of information. You may only see the A and the B up here. You may not see the bottom 2 lines. If you're not seeing the bottom 2 lines, then you're going to need to set your calculator so it will give you those calculations. So I'm going to show you. You might want to run through this with your calculator just to be on the safe side. If you look at the second of the 0 button, the second of the 0 button says catalog. So you're going to go there, second and catalog. When you go to second and catalog, you should get a screen like this. Basically, it is a catalog of all of the things that the calculator can do. You're going to scroll down that list until you get to something called diagnostic on. So it's right there. Put the little pointer next to diagnostic on and hit enter. So that says diagnostic on your screen. Hit enter again and it will say done. Now, if you go back and do that linear regression, even if you didn't get the bottom 2 lines before, now you will. So much faster to type that data in and let the calculator do the calculation instead of having to do that by hand, even when we only had 5 points. So if we have more points, definitely the calculator is going to be quicker. Let me show you StatCrunch real quick as well. So in order to calculate the correlation coefficient, there's actually more than one way of doing it. But if you just want to find the correlation coefficient, we can go to Stat and Summary Stats, which is where we've gone lots and lots of times. Instead of going to columns like we normally do, we're going to go to correlation. So Stat, Summary Stats, Correlation. Now, when I get this window, I'm going to choose the 2 columns that are my explanatory and response variables. So in this case, X and Y. Those were the names of the columns where I put my data. When I say compute, StatCrunch gives me the correlation coefficient in the window that comes up. So negative 0.93342. Again, the same thing that we got previously, both by hand and on the calculator.